Good? Okay, all right, great.
Not in it?
Right. Do we have a homework assignment?
No.
No, we didn't have one. Awesome. All right, great. We can start right away. That's awesome. Well, tonight you guys will have a homework assignment, okay? That'll be awesome. We're going to introduce a brand new function, right? We talked about what? Absolute values. We did the square root and cube root, right, Isabella? Now we want another one. No,
I love quadratics.
no. Evelyn said no. She said no. Oh, well, wait a minute. Julia said she loves quadratics. So, well, what Julia said, let's go. She loves quadratics. Let's do quadratics. Douglas, you know what a quadratic is? Oh, no worries. Because we're about to find out. What an exciting day. Oh, but before we do, this thing shuts off. You gotta turn the battery on and off and all that nonsense.
Wait, why are we? What's the video for?
Oh, I have to submit that with good people at George Mason.
Hi, George Mason.
Say hi.
Hey, like the elementary school?
What's that?
Like the elementary school?
Kind of. This is kind of like the, the college, but close.
I know.
All right. So what are we going to do today? Evan's like, okay, let's go. Today's Monday, right? Beginning of the week. Evan, we're going to introduce us. So because Douglas says, I know what it is, but I can't remember, so we're going to have a brief introduction to quadratics. Well, that's what we're going to talk about. And then we're going to have two different primary forms of quadratics. One is, this is my favorite part, the standard form, and the vertex form. And then we're at conclusion, and I'm going to hand out your homework at that point. You guys will probably be so in love, right, with quadratics, you want to go home and do even more problems. So, you guys remember that shape?
Yeah.
What was that called? Parabola. That is a parabola. That's right. And so I'm going to ask you, before we get started, on how we determine what the formula, like we did with the absolute value and the cube root and the square root. Before we do that, I kind of want to make sure we go over on being able to plug in values of x. Oops. There we go. For these three. So the very first one I want you to do is I want you to plug in x is 2 and tell me what f of x is. We're going to need to be able to do this when we graph these parabolas. You're going to take the value, see this x, instead of x, I'm going to plug in x equals 2 for each one of those three. So do me a favor, take a minute and go ahead and determine each one of them. Then we're going to go over it right here on the sideboard and make sure we're doing that right.
Even the x in the thing?
Oh, well, that's just, you could if you wanted to make it f of 2, right? Equals.
What I'm saying is like you plug everything.
You do, Julia. Then we want to make sure we can do that because we're going to create the 5-point table like we did with the absolute value, and then we did at the beginning of the square root and cube root exercises. These two should be 3x squared, 4x squared.
Oh, that makes sense.
Yeah. It worked 3x squared, 4x squared.
And then 2x is just 2.
That's just 2 times, yeah. Talk to your neighbor.
Yeah.
Make sure we're getting all getting the same thing. Good. Good.
For the third one, 3x is just 3
Times x.
Yeah.
I got it a different way.
Keep talking. I like that. the same page.
I don't know. You're gonna look way down. Wait. No, because this is what it says that for number 2, the 3 times 2 is 3 to the second power.
Oh.
Yeah.
This is 8 squared.
So I would get 8.
That's 4 times.
Yeah, that would be 9. So 3 to the second power.
Let's keep working.
Number 3, negative 4 times 2 is
Just to make sure everything's going all right, guys.
for number, yeah. So just,
Isabella,
yeah.
how did you do the first one?
So I plugged in all X's, so that'd be 2 to
So you plugged in what?
all the X's, so that'd be
So you plugged in what value for x?
2.
2. Okay, so what'd you do with this x squared here?
It'd be 2 squared minus 2 times 2 minus
2 minus 2 times 2 minus 3?
Yep.
And then what?
And then I solved for the square, which would be, I believe, 4.
4?
Yeah.
Minus.
And then 4 minus 3.
And what'd you get?
I got
So the first one was negative 3. Did everybody get that? CC, you got that?
Yeah.
All right. So we have negative 3 for the first one, but let's go to the second one. It's a little more challenging, right? Not much, but a little bit. So, CC, since we're talking, what'd you do for the second one?
well, I plugged in 2.
Awesome. That's what we want to do. And what'd you do here? So,
3 times 2 squared
awesome. Love it.
minus 2 times 4.
And plus.
Plus 3.
And what'd you get here?
3 times 4
Beautiful.
minus 4 plus 3.
Oops. Equals
11.
minus 4 plus 3 equals 11. Julia, did you get 11?
I didn't.
Oh, you told me a different thing.
Right? That's all right. You guys are working together. I like to see it. Okay, you guys on the third problem? Let's do the same thing for the third. Isabel, how's it going?
Good, you told me a different thing though.
I did.
Yeah, for number 2, you told me that it would be 3 to the second power, not.
No, 3x squared.
Yeah, I know. You
Oh,
told
well,
me
then
completely
sorry, it's 3
different.
times x
Yeah.
squared, yeah.
What?
No worries. How's it going, Jane? How's it going? Good? Good? Okay, great. All right. Alexa, I noticed you did that rather well. Tell me what you did with this third one.
Well, first I plugged in 2 for x.
2 for what? So you put
So
2
negative
squared here?
4 negative 4 times 2 squared.
Yep.
Plus 3 times 2 minus 2.
Okay. So you had negative 4 times,
Oh, negative 4 times 4
yep,
plus
plus
3.
times,
Oh wait, you want me to do it in the same step?
yeah, just 3 times 2
Plus
is,
6 plus 6 minus 2.
all right, so this is
Negative 16.
plus 4,
Yeah,
okay, and you got
negative 12.
negative 12.
Oh, I was like, what? Wait, what? I forgot the first thing. How does that work? Oh.
Well, let's see, you got it, yeah.
I know, but I didn't.
You got it. You did that? You got it. All right. Jane, did you follow that? We just plug in?
Yeah.
Awesome, awesome. So this is what we're going to do when we're graphing these quadratics, which we're going to do right now. We're going to do a couple exercises, and we're going to need to be able to plug in the values for x to find y. Remember we did that in absolute value, we created a 5-point table? Yes, Julie.
Okay, so I remember this vaguely.
Okay.
Is the f of x where you put the point, the end, like the end point thingy on the parabola thing?
Well, no, that's sort of, I know, an f of x is a fancy way of saying y.
Yeah, that's what I mean, like
Yeah.
that's where it is on y.
That's where it is on y, yeah. So that's what y equals, right. Very good, Jude, very good, good one. So, quadratics are going to be really, really important as you go on your mathematical career, scholars. Really important because a lot of things have square root relationships, a lot of them have squared relationships, right? And as you go on, you're going to need to be able to solve these, and you're going to hear the term quadratic equation an awful lot. Mr. Nickley is going to introduce you to that, and you're going to be, well, how do I remember quadratic equation? Well, the first way maybe is to think about why do we call it a quadratic equation? And the reason we call it a quadratic equation is that quadratum is Latin for square. And if I draw a square with sides A, what's the area of this square, Douglas? What's the area of this square if I had all sides are A? You take A times A. A times A. And what's A times A equal? A to the second power, and that's why we call it A squared, as opposed to the other one we thought. And why do we call it A cubed? Because the volume of a cube, if this were a cube, would be A times A times A. Right? That's why it's just easier to say A squared and A cubed. And then we just say A to the fourth and fifth and so on. But that's why when you see a power of 2, it's A squared because the area of that square would just be A squared. And that's why quadratics are called quadratics, because it's a square, quadratum for square. Meaning our second power, right, our leading term is going to be the second power. And that's how we'll recognize a quadratic. For example, like this one, right? Y is x squared plus 2x plus 3. Our leading term here, right, is x squared. It's a quadratic equation. A square, right? Not only we're saying square. Perfect. Our first of 2, right? We're going to do 2 today, and that's primarily the main forms of a quadratic equation. One is called the standard form, which I just showed you. And you probably guessed it. The general form of this is going to be y equals ax squared plus bx plus c. Fill in the blanks for what the values of a, b, and c are, right? But that's pretty much how we write it. We just say y equals some number times x squared plus some other number times x plus c. Now these numbers can be positive or negative, right? Those coefficients. They can be anything. It's a general form. But that's what it looks like. And when we're graphing, can you guys tell me what the first point we looked at when we did the absolute value equation? You guys remember that? I got the v, Evan. What was the point we were looking for?
The vertex.
The vertex, right? Where was that vertex?
For the parent graph, usually wasn't the vertex at the origin.
Well, I mean, in relation to this v, is it on the ends?
No, it's in the center.
It's in the center. Thank you very much, right? So it's in the center. The neat things about these quadratics are going to be kind of like the absolute values. The absolute value on the right side and the left side, Evan, since we're talking about the vertex, did they look the same? Did they look different? What did they look like?
They were the same.
They were the same. What are you guessing here with this x squared term? Emily, what do you think on this? If I find a vertex and I look to the right and I look to the left, what do you think they're going to look like? The same. And in mathematics, we have a special word for meaning the same. We call it they're symmetrical. They're symmetrical. And the axis of symmetry is going to run right through what point, Evan?
Vertex.
The vertex, meaning the right and the left halves are going to be identical, right? So, since we're on a roll, Evan, one more time, what point are we going to look for when we're graphing the parabola? The very first point.
The vertex.
The vertex. Thank you.
Place one and now we did quadratics.
I'm sorry, quadratics. Thank you. Wait, Redskins win, we're getting caught. Nice win. The vertex, CC. Right, that's the point I want to know. And we don't need to necessarily determine that, what the equation for that is, because they've done it for us. The mathematical people, they've come to, right, they solved the standard form, and they told us that the vertex is located at the negative b divided by 2a. So Evelyn, how do you think I find the vertex? And I'd look at whatever the equation was, right? And I'd plug in the value for b here and the value for a there. And there's my vertex. And when I'm creating my 5-point table, Jane, what's the first point I'm going to put in my little 5-point table? The vertex, right? And then remember when we did absolute values, then we looked for 2 points above it, 2 points below it, because the graph was symmetrical. Well, guess what, Julia? What do you think we're going to do here? Same thing, because it's going to be symmetrical. Whereas the absolute value equations, right, were these, we're going to see that these are going to be more like u's, right? So, with that said, we're going to graph together x squared minus 2x minus 3. And Emma, remind us, what's the first point we're looking for?
Vertex.
Vertex. Let's do it. Take a second. Let's find out what the vertex is. Ricardo, what do you think the vertex is? What do I do? In this case, my x is going to be, what's that? Just read the, right here. Tell me what that is. Over. Okay, so let's look at this guy. Which one is b? When we look at the general form, ax, sorry, I forgot this is a smart graph, smarter than I am. Ax squared, right, plus bx plus c. So, if I'm looking for a, what's a right there? There's a 1, right? 1 times x squared. And what's b? Negative 2. So it's opposite of negative 2 over what? 2 times, what's a? 1. Negative times a negative? Positive. 2 times 1? 2. So the x value of that vertex is going to be at 1. Now how do we find the y value? How do we find the y value? What's that? That was awesome. Is she right though? Would I plug it in, you think? To get it? What do you think? You think I can plug in? You think she's right? I plug in the value of x to get y? Does that sound reasonable? Okay, Julie, that was awesome. Let's do it, Julie, since she's very excited. How do I plug it in? We just did those exercises. What do I do? There's the equation.
1, well, pretty much, yeah. 1 to the
Squared?
square, and then minus 2 times 1 minus 3, which would be
1 minus 2 minus 3.
Wouldn't that be negative 4?
Negative 4. I'm sorry. Go ahead. I replaced them, right? This is to get the x. Yes. She asked, is this equation to get the x? And it is. That gets the x value. And as Julie said, we plug in that value to get the y value. Now I have the coordinate of my vertex.
What was the value?
1, negative 4. What's that?
Correct.
Yes. It's 1. That one right here. Right here. Minus b over 2a. And b, as Ricardo pointed out, was negative 2. And a, as he said, was 1. So I plug those back in. Negative of negative 2 over 2 times 1.
So if it's just an x equal 1.
Well, that's always, for any quadratic equation, I'm gonna use that to get the x value. And then, as Julie pointed out, what I'm gonna do is I'm gonna take that value, plug it into the equation, get the y value, and now I have my coordinates for my vertex. Yes, Ed?
How do you plug back the y value into the equation?
Well, I wouldn't have to, because I use that to solve that. You mean, well, when we go on to do our 5-point, we're gonna choose values of x's and determine y. So then we're gonna graph, which is our next step. So, while we're thinking about it, so we can do this exercise here, I'm just gonna hand out some graph paper. And if you guys would just pass that down. And we're gonna create our 5-point table.
I need
Everybody get one?
no.
There you are. Right, absolutely. You didn't get one? I guess I miscounted. There we are. So now we're going to create our 5-point table, and what point are we going to put in the center of that table? What do you guys think? So for x, 1, thank you. And for y, -4. So if I'm creating the table, which I want you to do on the side of your graph, I'm going to put 1, -4 right in the center. What kind of values could I use for x? I need 4 more points. And as Evan pointed out, above and below 1 should look exactly the same. So, Evelyn, give me some points. 2. 2 there for
3.
3. 0. -1 are great, all great points. Thank you very much. Now let's plug those in and get some values for y. I'm going to make a 5-point table right here. We're going to graph this here. Just like we did with the absolute value equation. We're going to plug them in just like we did it at the beginning of class. So that's a general formula. A could be anything, B could be anything, and C could be anything. No, I don't have to. The equation tells you. What's in front of that x? So A is 1. What's in front of that x? So B is -2. And what's this? So C would be -3. You use. Yeah. No, you're gonna plug these values in for x. Right here. Because you used this equation right here, and we found the vertex, which we put in the center of our graph right here. Right? Now we're gonna figure out the values above and below it, so that we can plot the absolute value, like we did with the 5-point tables there.
I don't know if I did this.
Well, we'll go over it. All right, let's. Oh no, we're not gonna. I'm just gonna plug in one value, make sure we're all on, and I like 0 because 0 seems really, really simple. I love that you chose it. If I'm throwing 0, Evelyn, since you chose it, what would that equal? What would y be? Just plug it in. 0 times 0?
0.
Awesome! 2 times 0?
0.
And what am I left with? -3.
That really just messed up.
There you go. Right, Cece? Yeah, that's why we want to make sure we know.
It's just not symmetrical, you know? It's just every spot.
Wait, how do I go? How do I do that? Can you go over one of the?
Oh, sure, another one too. Let's do -1.
Between -3.
Yeah. 1 minus 2, so that's +2 minus 3, right? So x squared, what I should have done is y squared minus 3, it would have been very. So let's change this graph just ever so slightly.
What?
Yeah. So what we're gonna do is we're gonna make this x squared minus 3 in the next class, because it is going to be, but it's gonna be easier for us if we make, well, anyway, we'll just, I'll tell you what. Let's
It's
just,
not even making it, it's not even a function.
it's a function,
I-
but, let me show you.
A good function.
Alright.
Yeah, I definitely did not.
Let's do,
So confusing.
there it is.
Yeah, you guys know.
So if I have, what did I write, x squared,
Hey.
right? Minus, what was b, minus 2?
Minus 2x, yeah.
Yep.
Now this whole thing.
And c was plus 3?
Minus 3.
Minus 3? Alright, thank you. There it is. Now notice this point here. Make sure I can show you guys. What's that point right there? Yeah, the vertex. And what is that coordinate?
Oh, like 1, -4.
Right, 1, -4. And what did we say that 0 was? 1, 2, 3?
Okay, now it's.
Now it should be. Good. I was hoping that if I put it up, it might come up.
I just like
And what's, so if I look at 0 being 3, let's plug 1 in. Alright, so we had ax squared, 1x squared, minus 2x plus, is it minus 3? Minus 3, right? Alright, let's plug in
Can you 3?
3. Let's plug in 3. So we have 3 squared minus 2 times 3 minus 3. So this is 9 minus 6 minus 3. I'm getting 0 for that,
I
right?
figured
No,
that out,
I
but what
got-
about negative, when I got -6?
1, 2, 3 is 0. There it is.
Yeah, but then for -1, I got.
Oh, okay.
I got -6.
Let's,
3.
well, let's do -1.
Okay, we need to with that one.
All right, f of -1, right, is equal to -1 squared, right? Minus 2x, well, minus 2 times -1, sorry, minus 3. Yeah, so this is what, 1, and this is plus 2. This is minus 3. I thought it might be easier if we, so f of -1 is 0, right?
Wait, hang on.
That's why I put the graph up, I wanted it so we could see it.
I got it.
I thought you could do this. Yeah, so how'd you get 2? Which one?
Yeah, because you just went from that to 1 plus 2 minus 3.
Here? Oh, so this is -1 squared,
Okay.
plus this is minus 2 times -1. Negative times a negative is a positive.
Yeah, I know that.
Minus 3. 3 minus 3.
How did I not get that?
That's okay, that's why we're doing this one.
I'm trying to figure out where I messed up.
Well, what about 2? What do we get for f of 2?
-3.
Well, let's see. Yeah, let's move this out. We can. That's all right. That's why. All right. Try to make it. That's all right. F of 2 is equal to what? 2 squared, right? 2 times 2. All right. 2 squared minus 2 times 2 minus 3. So this is 4 minus 4 minus 3. F of 2 should be minus 3, right? 1, 2, 3. Perfect. F of 2 is minus 3. I thought it might be easier. I was going to. So when we graph it, right? Perfect, by the way. It's perfect. Right? I just thought it might be easier this time. The next one you're going to do without me putting it up first. -1. How do we do that? Evan, help me out.
You plug it in the X spot.
Excellent. And you get minus 1 squared,
Yup,
minus
and
2
then-
times negative 1,
Yup.
minus
And
3,
then
what'd you get?
And then, you do -1 squared is just 1,
1.
and then,
No, I didn't get that, you did it wrong.
2 times, negative 2 times negative 1?
so you did
That's
2
not even
times
wrong.
negative.
2?
Yeah.
So 3 minus 3 is
I don't know what you did.
0? Yeah. And look right here. There it is. What do you notice about that graph, Evan, that we were saying earlier? Around the vertex?
It's symmetrical.
It's a symmetrical graph around that, right? So the axis of symmetry would be right down that x equals 1, right? If I drew a line right through there, the left half and the right half would be the same, wouldn't they? Right, Ricardo? They're exactly the same. And that's what this showed, right? Did everybody get this table?
Yep.
Jane? You got it? You see this is our parabola. Now we're going to do one where you're going to do it before I put it up on the graph. And you're going to tell me what it looks like. But I thought it might help that time if we looked at it, and I think it did. You can kind of visualize what's going on. You guys learned end behavior, right, last time in the exam? What's the end behavior of this graph? It's up, up, up. And how do we say that?
X goes to infinity, Y goes to infinity.
And what about as x goes to negative infinity, Alessia?
Y goes to infinity.
That's right. And why do you think that is?
Because they both go up.
Why do they both go up?
Because it's a,
Yeah, because the leading term is this x squared, right? And that's going to be a lot bigger than any other term, Alexa. Now, what if I put a negative in front of it? What would happen?
they would go down.
It would perfect. How do we say that? We say it's going, is that going up or down? It's going down. So if we see a negative term in front of that for A, we're going to expect this term, CC, this graph to go down. All right. Let's. Perfect. All right, now we know the standard form. In front of you, you have two graphs on the standard form. We're going to do the first one. Okay, sorry. There's our standard form. So I'm just going to, I wanted to put that up there so you can see what the equation for the vertex is. The graph you're going to do is the very first one there, x squared minus 6x plus 3. Once again, Evan, what's the first point we're looking for?
The vertex.
The vertex. The vertex, right? So it's opposite of
in front of
opposite of negative 6. Yes, and then it's over 2a, and a is 1, not x squared. So we're looking at a
So
right in
it's
front of it.
6? Does it have to be opposite? What
It's opposite of b.
Okay, so if an equation is negative 6.
Right, so the opposite of negative 6 is, there you go.
So it's just 6 over 2a minus 1.
Love that, Jack. Crush. So that would make a1. Right, 'cause all right. Before we go on to the other points, I want you guys to tell me what the vertex is.
3.
Awesome. Let's, whoops, this is fine. So I did what? I said the x value for the vertex was up negative b over 2a. And what was b?
B is
6.
but it's 6.
Awesome. And what's a? 1. So I get 6 over, sorry, put a there, 2 times 1, 2. And what's that? 3?
Yep.
And when I plug that in, what do I get? What's our equation here?
I thought it was.
Y equals x squared minus 6x plus 3. So I plug in 3 squared minus 6 times 3 plus 3. I get 9 minus 18 plus 3. And I get what? Minus 7? Is that right? Did I get that? Everybody?
No.
No?
I got negative 6.
I'm sorry, I missed one. You're right, I had 11 and 6. Yeah, 12. I did not. Sorry, minus 6. Thank you. I make a mistake every once in a while. Yes, it's minus 6. Thank you for correcting that. Oh, sorry. It's not. It looks like a C. My handwriting's not as good as yours. There. Is that?
handwriting is really bad.
No, mine's worse. There you go. So that means the very first point I should be putting on that table should be 3 minus 6, right?
Yes.
Awesome. Let's make our little table here,
Ooh.
and I'll let you guys work on it. Okay.
Just to let you know, the graph is upside down. Douglas just pointed that. The graph is upside down.
Oh, thank you, Douglas. Well, ignore the upside down components.
This will just write it on our own way.
Yes, sorry about that. I'll make sure. Thank you, Douglas. But at least the graph should look good. Yeah. How's it going? Good. The table. You see, you got the table. Let's do some points. You guys are going to tell me this time what this graph looks like.
Am I not allowed to? It's a free country. It's America. 20. This is new for Jeff.
Yeah, sure.
Someone else there.
All right, guys. That's not so awesome. Let's try 2. All right. Just to make sure we're on the same page, Evelyn, what numbers did you choose again? 1, 2, 3, 4, 5. I couldn't pick better numbers, right, guys?
Yeah, right.
Iman, you think those are good numbers? They're great numbers. You bet. No, thank you for picking such great numbers. How we doing?
So the first thing we did is we got the vertex, at 3, which this would have been negative of -6, so that's why this is positive. Is a negative of negatives. You got it. And then we said, oh, this is at 3 negatives. Could we plug that back in? We got -6. So we have 3 -6. And then we're just going to plug in 1, 2, 4, 5. Okay? 2, 3. That's where the vertex is.
How'd you get that?
Wait, no,
And that's where our
that's not
axis of
negative
symmetry should be,
I
right?
think I'm wrong.
I think I'm wrong.
You can check. No, what?
Exactly. As long as it wants to try your best.
All right.
I got negative.
Wait, what? No, I got 16.
Which one are we doing?
4 is 16.
Which one is
Because I
it?
didn't, well, you did negative
Oh.
6. I don't.
This one.
Negative,
Wait,
you're looking at 4?
No, wait, yeah.
I'm just going with the.
Yeah, no, because 4 times 4 is not 8. 4
Up
times.
going.
Wait, you do it like
That's right. And you can check yourself, right? Just like the 4 should be the same.
Yeah. Ooh, I haven't been embarrassed. I was like, wait, I did math.
I know. It doesn't like terms. I think statistics bring terms. Yeah, go ahead. Hurry up there, so we're gonna go. What do you got there? Which one is that?
25.
Is that for 1? Well, let's find out. All right, Evelyn wants to help us with 1. Make sure we're all plugging in our first point. Evelyn, plug it in for us. Plug in 1. 1 squared minus 6 times 1 plus 3. And what do you get there? 1 minus 6 plus 3. And what'd you get to that? So 4 minus 6 is equal to, did you get minus 2? Minus 2.
Sure.
Did everybody, Evan, did you get that? What? All right. Come on. Help me out with 2. Did you do 2? What'd you get for 2? 2 squared? Okay, minus 6 times 2. All right, plus 3. And what'd you get? 4, 12 plus 3. So this is what? Minus 8 plus 3? What'd you get? Minus Negative 5. Negative 5. She said that's negative 5. All right. Jane, what'd you get for 4? Y equals, so we're going to put 4 squared, right? Oh, sorry. Jane, still working on that? All right. Julia. Oh, I see you've got a nice graph there. What'd you get for 4? Tell-
4, I got negative 5.
Well, 4, let's go through 6 times 4.
Yep.
Plus 3.
Yep.
So I've got 16 minus what?
24
Plus 3.
plus 3 was 24.
Negative 8 plus 3 is equal to negative 5. All right. And now remember, Evan told us that a parabola looks the same on the right side as it does at the left side of the vertex. And he also said that the x-coordinate for that vertex is going to be our axis of symmetry, just like we did in absolute values. Only instead of v's, we're getting u's. And so he said that if this is my axis of symmetry, right here, of symmetry, which then I should look at the y values here should look the same right here, right, Evan? And we can, so like we did in absolute values, Douglas, we can check our math. So it's a good way. If I go through it again, I should get the same value. So Douglas, let's do 5. Let's plug in 5 and see what we get. 5 squared, 6 times 5. And 5 squared is 25. 6 times 5? 30 plus 3. This is negative 5 plus 3. And what'd you get? Negative 2. You guys see that? Emily, Jane, they're the same. So that looks good. So who can tell me what the graph looks like? What's it look like? A U. And where is that vertex?
Negative 6. Well, 3 and
Yeah.
All right.
oh, I thought extra negative.
All right. So we had what? X squared minus 6x plus 3, right? Is that kind of what your graph looks like?
I'll get back to it.
Is that sort of what your graph looked like?
Yeah.
Mr. Walmart, something happened to the camera.
Probably about to run out. Thank you. Thank you. It's just telling me my battery's running low, which I already knew, even though I ordered a cable, it didn't come in, even though Prime said, and I paid for it 1 day shipping. It
That
didn't
is
come in
ridiculous.
yesterday.
Sue whatever.
I know, so because I knew I had
Amazon
to do
Prime.
this.
Sue Amazon.
So, Evan, did your graph look like this?
Yes.
Isabella, what's your graph? Does it look like this?
Yeah,
Did
it
you
might
see?
be a little bit floppier, but yeah.
That's fine. Do you have your vertex at,
Yeah.
let's see, 1, 2, 3, negative 6, right? Perfect, Julia. All right, and then you can see how it's symmetric, right around. And if I were to draw a line on x equals 3, that would be an axis of symmetry, right? Both the right and the left would be identical around that line. What is, here's a good question for Cece. What is the lowest value of y?
Looks like it's -6.
And where does that occur? And what's that point called? And why is that the lowest value? Because does this graph point upward or downward, Alexa? So if it's pointing upward, it's moving away from the vertex, up or down? It's up. Every other point is going to be above that vertex because we're pointing upwards.
Range domain.
So, now if it pointed downward, Alexa, if it pointed downward, if all I have to do, right, is to change it, it'll change the shape a little bit, but if we made that a negative, that leading term, a negative, so if we make a negative right here,